The topic is using what you know about proportion relationships. The essential question is, can you use what you've learned about unit rates and proportionality to complete the info? So the first situation states that peaches cost $2 per pound at the market. So to find the unit rate, you should hopefully know that cost would go in the numerator, and therefore in the denominator would be the pound, and it's $2 per pound. And you see that per pound right there? That means it'd be $2 for every 1 pound, okay? And I'm abbreviating pound with LB. And that's already a unit rate because you see 1 in the denominator, because $2 per pound, that's the unit rate. So I'm just going to kind of remind myself that to find unit rate, it's y divided by x, okay? So with that being known, we can go ahead and start on our table. Our table is blank, but you know that the first column represents x, the second column represents y. And then since I need to label it in the context of the problem, I have this labeled x, and remember how you labeled this x? You can look over here and see that x represents pounds. You know, pounds of peaches. And then y represents the dollars, or the cost, or cost in dollars. Okay? From there, let's go ahead and you can pick any values you want to plug in for the independent variable. So if you're curious about how much 100 pounds of peaches would cost in this context, go ahead and write that. But remember, we're going to be writing a graph later on, and you may not want your graph to go that high. So I'm just going to use my 0, 1, 2, 3, 4, and oh, look right here. It's asking how much would 42 pounds cost. And although I probably won't include that on my graph, I can use it, put it right there to determine the cost, because I can also get that answer from my table. And then it says, how many pounds could you get for $120? Well, I wouldn't put the $120 here because this is the pounds section, so I put it in the cost. So I'm going to extend this just a little bit and put 120 right there, okay? Well, since you know that the unit rate is $2 per pound, if you get 0 pounds, then you know the cost is 0. But if you get 1 pound, you know you'd have to multiply that x value by the unit rate of 2 to get the corresponding y value, which would be the cost. So just to kind of remind myself, I'm just going to go ahead and write down that unit rate throughout this entire column right here so I remember what to do. Okay, so 2 pounds of peaches would cost $4, 3 pounds would cost $6, 4 pounds would cost $8, 5 pounds would cost $10, 42 pounds would cost, let's see, 42 times 2 is 84. And then when I get down to here, you're going to see, well, we don't have a value for the pounds, but we know that the cost would be $120. We also know that the unit rate is $2 per pound, so to go, typically we go this times this to get this, so to go backwards you'd go this divided by this to get this. So 120 divided by 2 is 60. So right there we have answered the questions for right here. But that's not the only way you can come up to the answer of this. You could also use proportions, you know, set up the 2 equal fractions. And I'm also going to do that because you also should have exposure and practice to that. So remember the unit rate was $2 for 1 pound. And they're concerned about 42 pounds. How much would that cost? Since it says 42 pounds, I'm going to put that in the denominator. And you got to think to yourself, well, how did I get from 1 to 42 using multiplication or division? Well, we multiplied 1 by 42 to get the 42, so we also have to do that to the numerator. 2 times 42 is 84, and that would be $84. So to answer this question, it's just $84 is how much 42 pounds would cost. And look, it also matches in our table. 42 pounds costs $84. How many pounds could you get for $120? Well, I already know that the answer is, what, 60? But I want you to get practice with using proportions also to help you figure out your answer. So I'm starting with the unit rate, it's $2 for 1 pound. And I know that they're wondering how much they can get for $120. So since it's dollars, I'm going to put that in the numerator because it matches up with here. And how did I get from 2 to 120 using multiplication or division? Well, I would have to multiply by 60. And if you're like, how did you get 60? You can go 120 divided by 2, which is 60. So I knew I had to multiply this 2 by 60 to get that value right there. So I must also do that to the denominator. 1 times 60 is 60. And make sure you label it 60 pounds. Okay? So how many pounds could you get for $120? It's also right there. You could get 60 pounds. Okay? Let's move on to, let's go ahead and do the equation. Toss things up a little bit. For the equation of this proportional relationship, you want to write y equals unit rate, save spot for unit rate, times x. And I'm going to use x and y simply because it doesn't tell me to use any other variables right there. If it told you to say, hey, x would represent, use p to represent pounds, and then c to represent cost, then I would use different variables for that, okay? And they would usually indicate that. But when it's not stated, I would just use x and y. And the unit rate was $2 a pound. And I'm going to go ahead and label that right there. So that's the unit rate. And what that means is it costs $2 per pound. And then X represents, well, if you forget, you can look at how you labeled it here. Oh, it's pounds. And if you're like, oh, I can't read my handwriting, look over here. Oh, it represents pounds. So it'd be pounds, number of pounds. Specifically, it'd be pounds of peaches, but you don't have to get that detailed, I don't think. And then Y would represent the cost in dollars. And it makes, I hope that makes sense to you because, you know, Y is the dependent variable, X is the independent variable. The cost depends on how many pounds you get. So that's why this is dependent and this is independent, okay? All right, let's go on to the graph. And you know that this axis right here is the y-axis and this axis right here is the x-axis. And the x represented, if you forget, you can look right here, x represents pounds. You're going to be consistent throughout the entire thing, throughout all of those representations. And then y represents the cost. Okay, let's go ahead and plot some points. I'm going to count the x-axis, the intervals I'm going to use, I'm just going to count by ones. So that first little notch is like that right there is 0, 1, this would be 2, 3, 4, 5, 6, 7, 8, 9, 10, and that would be 11. So if you're curious why I just did that, it's just because I didn't want to squish all my numbers there, but you'll notice I'm still counting by ones because I didn't put a number there, but you should all hopefully know that between 1 and 3, if I'm counting by ones, is 2. Right here would be 4, this would be 6, this would be 8, this would be 10, okay? And for the y-axis, when you're graphing like a proportional relationship, it's a pretty good idea to maybe jump by your unit rate just because it would make things easier, but you don't have to. My unit rate's 2. So this little first notch right there is 0. This right here would be 2. Right here would be 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. Okay, and again I did the thing where I am counting by 2. See, this would be 2, 4, 6, 8, 10, 12, 14, 16, so on and so forth, but I didn't write it because I felt like with my handwriting I would just smush it. Okay, all right, let's go ahead and plot our points. You know, you don't have to plot all the points on here because I don't really want, my graph doesn't go to the x-axis doesn't go to 60 and my y-axis doesn't go to 120, so don't worry about those, but we can plot 0, 0, the origin. And then we have 1, 2. And then we got 2, 4. That right there is 2, right there is 4. And we have 3, 6. And you'll see that there is a pattern because this is a proportional relationship. So I can continue it. Okay, now, right now as it is, it's discrete. But think about it. We're looking at the x value right here. Can you buy like 1.5 pounds of peaches? You can. So therefore I'm going to connect these dots and make this continuous, okay? Well, I should use a straight edge. And I'm also going to include an arrow at the end of that just because you can really buy a ton of pounds of peaches. Okay, this is really hard. Oops, see, I even messed up. Oh, darn it. Okay. Pretend that's a straight line. Okay, so we filled out all 4 representations right here of this proportional relationship, and now it's time for the summary. How do you find the unit rate from a proportional situation? So from when you're given a proportional situation like this, how did you find the unit rate? Describe it. And the second summary question is, how did you find the unit rate from a proportional table? So looking at this table right here, if you were just given a table like this, and you're told it's proportional, how do you find the unit rate? Okay. This situation says that chicken costs $8 for 2 pounds. So to find the unit rate, we are going to go ahead and use the rate that they gave us here. It's $8 cost in the numerator for 2 pounds. And to find the unit rate, we want 1 in the denominator. And to get from 2 to 1, we didn't subtract 1, we divided by 2, okay? 8 divided by 2 is $4, okay? And that's the unit rate. So just a little reminder to yourself, put a y divided by x like that, okay? Now, I can fill out the table right here. So it's blank. I have x and y. X represents, aren't you happy you labeled it? It represents pounds. Pounds of chicken. And the dependent variable y represents the cost in dollars. And you can pick any values you want for x, but I would just try to stick to smaller numbers just because I know I'm going to have to represent it in a graph. So I'm going to go just 0, 1, 2, 3, 4, 5. And the unit rate was $4 for 1 pound. So for 1 pound, it was $4. And to go from 1 to 4, we had just multiplied by 4. So I'm just going to write that down this little column right here so I can easily just look at it and figure out the cost. So 2 times 4 is 8. So 2 pounds would cost $8. 3 times 4 is 12. 4 times 4 is 16. 5 times 4 is 20. So 5 pounds would cost $20. Okay? I see over here how much would 3/4 of a pound cost. Well, when you go 3 divided by 4, you get 0.75. You can keep it a fraction if you want, but I just like converting it to a decimal because sometimes I type it in my calculator. So this is the same as 0.75. Okay, that's an equal sign. And that's in pounds, so I'm going to put that in this column right here just so I can come up with the value. And I know I got to multiply it by 4 to get the corresponding y value. Oh, and there's another question here. How many pounds of chicken could you get for $196? So that's dollars right there. And that would not go in the pound section. That would go in the cost because it's $196. And we can continue with that multiply by 4 right there, okay? So to figure out this corresponding value, the y value for this 75 hundredths of a pound, I would go 75 hundredths, or you could type in 3/4, same thing, times 4 equals 3. Okay. Like I just said, you can also type in 3/4 instead of the 75 hundredths. So 3/4 times 4 equals 3. So you get the same answer. Okay, so typically you would go this number times 4 to get this number, but we got to go backwards because we're getting this x value when we're given the y value. So we got to go 196 divided by 4 to get this. And it's 49. So 49 pounds would cost $196. And I also want you to do it using a proportion. So how much would 3/4 of a pound cost? I'm going to start with that unit rate. It's $4 a pound. And they're concerned about 3/4 of a pound, so I'm going to put 0.75, 75 hundredths. And to go from there to there, I multiplied by 3/4 or 75 hundredths. So I must also do that up here in the numerator. And when you go 4 times 75 hundredths, you would get 3. Don't forget your dollar sign. $3. That's how much it would cost. And see, it also matches in the table. Okay. How many pounds of chicken could you get for $196? Just like I did up here, I'm going to start, I'm going to use a proportion. Start with $4 for 1 pound, and that was my unit rate. And they're curious about how many pounds you can get for $196, so I'm going to put 196 in the numerator. And how did we go from 4 to 196? What did we multiply it by? Well, we need to, the way to figure this out is I go 196 divided by 4. And that's 49. So I multiplied 4 by 49 to get the corresponding value right there. Ooh, I don't know if you can read that. That says 49. So right down here, I'm going to multiply by 49. 1 times 49 is 49. So it's 49 pounds. Which also matches right here. 49 pounds costs $196. That says 49. Okay, and I'm going to circle it so you know that's the answer right there. So from here, I'm going to go ahead and let's go with the graph. This is the x-axis. This right here is the y-axis. I'm going to go ahead and label everything. X represents pounds, and y represents the cost, and that's the cost in dollars. Okay, so the pounds, I'm just going to count by ones. So that first little notch right there is 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And just because I didn't write the numbers there, all of them, that doesn't mean they don't exist. You'll see by the notches, between 1 and 3, that's 2. This is 4, this is 6, okay? So don't get confused, please. For the y-axis, when you're dealing with a proportional relationship, it's easiest to use your interval, make your intervals count by your unit rate, and our unit rate was 4, so I'm going to count by 4s. So right there, that would be 4. Well, this first little guy right there is 0, but that's 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, and you can keep going if you want, but you don't have to. That signifies that it'll go on forever in either direction, okay? So let's go ahead and plot some points in there. We know, I'm going to start with the unit rate. 1 pound costs $4. That point right there, that's the unit rate. When x is 1, the corresponding y value is the unit rate. So that ordered pair of 1, 4 represents the unit rate in a proportional relationship, in this specific one. All right, and then 2 pounds costs $8. Oh, 0 pounds costs $0. 3 pounds costs $12. And you can just kind of get some values from your table, or you know, you can continue this pattern right here, as long as I counted correctly on my x and my y axis. Okay, now you got to think of this. Does it make sense to turn this discrete graph into a continuous graph, or a continuous line, I mean? Can you buy, at a store, grocery store, can you buy like 2.5 pounds of chicken? Yeah, since you can have incremental, or I mean fractional parts of pounds, then that's why I'm going to connect it. It all really depends on the x, okay? So, and I'm not going to really bother with using a straight edge simply because it's kind of hard to do it with a camera. But pretend that this is a straight line. Let's put an arrow in there. Okay, so this line should be, linear, and it crosses through the origin because this is a proportional graph to represent the proportional table to represent the proportional situation. And this equation is going to be a proportional equation. So it's going to be y equals unit rate. The unit rate was 4 times x. X represents, if you forgot, you can look at your graph, your table, or your situation. X represents pounds. The dependent variable of y, if you forget, you can look at any one of the situations right here, the little boxes, and it'll show you y represents cost. And that 4 right there is the unit rate. And that would be $4 per pound. Okay? All right, for your summary. On a proportional graph, how do you know which coordinate represents the unit rate? How did you know which coordinate, so which point, represents the unit rate? The next situation says that you ran 2 miles in 40 minutes. And the unit rate, to find that, let's see, we would put, well, I know time typically will always go on the denominator, so I want that on the bottom part of the fraction. And then distance typically goes in the numerator, so that's going to go on the top part of the fraction. So 2 miles in 40 minutes. Let me read minutes with MIN, okay? That's not the unit rate, that's just the rate. So let's go ahead and find the unit rate. So I want to know how many miles can they go in 1 minute. So I need to divide by 40, because 40 divided by 40 gives me 1. And then 2 divided by 40, I got 0.05. So that's what, 5/100ths of a mile? So that's the unit rate right there. And please remember, unit rate is y divided by x. I'm going right in my table, sorry. Okay, so let's go ahead and fill out a table. X and then y. X represents minutes. Y, which is the dependent variable, represents miles. And you can pick some values you want for the minutes, but I'm going to just go 0 minutes, 1 minute, 2, 3, 4, 5. That looks good. All right, so if you had 0 minutes, how many miles did you go? None. If you were running for 1 minute, how many miles did you go? 0.05, 5/100ths of a mile. And I'm going to continue that because this is the unit rate. Right here is the unit rate because that's the unit rate. So I'm multiplying by 5/100ths each time. Sorry, I can't see my decimal there. So 2 times 5/100ths is 1/10. 3 times 5/100ths is 15/100ths. 4 times 5/100ths is 2/10ths, or you could also say 20/100ths if you want, that's the same thing. 5 times 5/100ths is 1/4. 0.25 is the same as 1/4. 1 divided by 4 is 0.25. Okay, I'm just trying to be more flexible in my wording here. Let's figure this out. How many miles how many miles did you run in 48 minutes? 48 is minutes. I know I got to multiply by this unit rate. And then how many miles did it take to run 4.5 miles? How many minutes did it take to run 4.5 miles? So that's 4.5 miles. It goes in this miles department. Looking at 4.5. And I knew I had to take that x value and multiply it by the unit rate of 5/100ths, okay? All right, let's go ahead and let's figure this out. 48 times 5/100ths. 5/100ths. 2 2/5. Okay, another way to say 2 2/5 is 2 4/10. Okay, and we got to go 4 5/10 divided by 5/100ths. You get 90. So it took 90 minutes to go 4.5 miles. Okay, so up here, let's go ahead and I'm going to show you with using a proportion. I'm going to start with the unit rate, 5/100ths of a mile in 1 minute. And they're concerned about 48 minutes, so I'm going to put a 48 to correspond with the minutes, because that's minutes. 1 times 48 gives you 48, and then 5/100ths times 48 gives you 2 4/10 miles. Okay? Which is what we got right here. How many minutes did it take to run 4.5 miles? Start with that unit rate. And we're concerned about going 4.5 miles, so that's going to go in the numerator. So to go from here to here, what happened? Well, to figure out the multiplier, I'm going to go 4.5 divided by 0.05. It's 90. So I took this and I multiplied it by 90 to get this guy. So I can multiply this guy by 90 and get 1 times 90 is 90. 90 minutes. That's how long it took to go 4.5 miles. And it also matches right here, which you would also match in the graph as well. However, I already know that my graph's not going to go up that high, but eventually it will. Like if I wanted to sit here and write all the numbers all day, then it would totally work, and I could use that to find the answer to this. But my graph is only so big because my paper's only so big, and I just don't want to write that many numbers. So the x-axis is this one, the horizontal one. The vertical one is the y-axis. I'm going to count by just one, so that's 0, 1, that says 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And x represented the minutes. And the y-axis represents miles. And I'm going to go ahead and jump by the unit rate. Oh, this is going to be tricky to count. So that first little notch is 0. The first, like that one right there. And then this one right here would be 5 hundredths. Okay, 5 hundredths plus 5 hundredths is 0.1, 1/10. But I'm not going to write it because I don't want to be all smushed. So this would be 15 hundredths. And then add 5 hundredths to that, and you would get 0.2, 2/10 or 20 hundredths. So then this would make this 25 hundredths. And I'm going to just go ahead and say it incorrectly mathematically because I'm trying to add. So 0.25, this would be 0.3, this would be 0.35. Right here would be 0.4. Right here is 0.45. Right here would be 0.5. So this would be 0.55. Right here would be 0.6, so this would be 0.65. Right here would be 0.7, so this is 0.75. Right here would be 0.8, so this is 0.85. Okay, let's fill in our values. Just some of the values in here. 0, 0, 0, 0. And then I'm just kind of looking at the table. I know I'm not going to put the camera up there. 1 and 1 comma 5 hundredths, 2 comma 1/10, and so on and so forth. And I know that like this 0.11 comma 0.55 is not in the graph. I don't have an 11 and the corresponding y value of 55 hundredths in the table. But I know it'll continue that pattern, okay? So now it's discrete. I haven't connected the dots yet, but does it make sense to connect the dots? Look at this, minutes. Could you have like 1.5 minutes when you're running or 2.5 minutes when you're running? Yeah, you can. So we're going to connect it and make it continuous and try your best to make it a straight line. And I'm going to put an arrow on there because it makes sense to continue that. All right, for the equation, y equals unit rate times x. What was the unit rate? That. 5 hundredths times x, and this right here would represent minutes, and this right here represents miles, and this is the unit rate, which is 5 hundredths, or you could say 5 hundredths miles per minute. Okay, instead of writing the equation as y equals 5 hundredths x, is it okay to write y equals 5 hundredths x? Why or why not? This situation says that 10 candy bars cost $5. So to find the unit rate, we're going to use that information right there. Cost in the numerator, so $5 for 10 candy bars, and I'm just going to write bars. And to find the unit rate, we want to know how much does 1 bar cost. And to go from there to there, we just divided by 10. 10 divided by 10 gives you 1, so 5 divided by 10 is what I got to do. And 5 divided by 10 is 50 cents. Remember, do the little y divided by x right there to remind you, because it helps you when you're creating your blank table here. X represents number of bars. Y represents the cost in dollars. Let's go ahead and just pick your values for the independent variable. 1, 2, 3, 4, 5. And I'm going to plug in how many can you get for $45? Oh, I'm going to put a 45 right here, because that's the dollars. And how much would 27 candy bars cost? 27 candy bars, that would be number of bars. Okay. All right, let's go ahead and figure this out right here. How many can you get for $45? So I'm going to start with that unit rate of 50 cents a bar. You can write 0.5 or 0.50 for 1 bar. And they're wondering about how many you can get for $45. So I want to put 45 in the numerator and figure out how many bars we'd get. So how did I go from here to here? What did I multiply by? What I had to do is I need to multiply 45 divided by 0.5 or 0.50 to get, what did I multiply? Multiply right there by 45, oops, that's not 45. 45 divided by 0.5, I got 90. So I had to multiply this by 90, so I had to multiply this guy down here by 90. 1 times 90 is 90. That's how many you can get, 90 bars. So I know right over here, for $45, I can get 90 bars. How much would 27 candy bars cost? I don't know yet. 50 cents per candy bar. And they want to know about 27 of them. So how'd you get from here to here? Oh, we just multiplied 1 by 27 to get that guy. So I got to multiply 0.5 times 27. So 5/10 times 27 is $13.50. Let me double check that. I might be wrong. 5 times. Oh, okay, we're good. And that's how much it would cost for 27 bars. So 27 bars cost $13.50. So to continue with this little table here, the unit rate was 50 cents per bar. So if you got 1 bar, it's going to cost 50 cents. But we multiplied by, you can write a half if you want. Let's write a half, because that's the same as 0.5 or 0.50. Because 0.5 and 0.50, they're interchangeable, and so is 1/2 with it. So what's half of 2? That's 1. What's half of 3? Half of 3 is 1 1/2. Half of 4 is 2. Half of 5 is 2.5, $2.50. And that's all I got. Oh, 0. If you didn't buy any bars, it doesn't cost anything. Okay, now I'm going to go ahead and I'm going to do the equation now. Y equals unit rate. I can write 1/2 times x. Or, you know, I could totally write y equals 0.5 times x. Or I could write y equals 0.50 times x. Or I can write y equals 0.500000 times x. X represents bars, number of bars. Dependent variable of y represents the cost in dollars. And same thing down here. And then this right there, that's the unit rate of 50 cents per candy bar. Okay, and you can draw the arrow up there too. Okay, graph. X-axis, y-axis. X represents number of bars. Candy bars, to be more precise. Y represents cost in dollars. Go ahead and label your intervals on your axes. That's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, for the y-axis, I'm going to count by the unit rate, which is halves. I'm going to do decimals, so instead of 1/2, I'll do 0.5. Okay, so that's 0, 0.5. This would be 1. This would be 1.5. This would be 2. This is 2.5. 3 and 5 tenths, 4, 4.5, 5, 5.5, 6, 6.5, 7, 7.5. There is 8. That's 8.5. Or $8.50. Okay. Now I know that 0 candy bars cost $0. I know that 1 candy bar costs 50 cents. I know that 2 candy bars cost 2 candy bars cost $1. 3 candy bars would cost $1.50, and so on and so forth. Now, think of this. When you go to the grocery store, are you able to buy 1.5 candy bars? So like have a point like right here. No, you can't buy 1.5 candy bars. Yeah, you can eat 1. You can eat 1.5 and have some left over, but when you purchase it, it's in whole increments. So that's why I'm going to keep this as discrete. But you know, we can put a little old arrow on there. It looks kind of weird. Okay. All right, for your summary, how do you find the unit rate from a proportional equation? So here's a proportional equation. How do you find the unit rate from it? This situation says it takes a faucet 3 minutes to fill a 5-gallon bucket. Find the unit rate. So I see time right there. I'm going to put that in the denominator because that's independent. And 5 gallons is dependent. And I need to find the unit rate. So I want to know how many gallons get filled in a minute. So to go from here to here, I just divided by 3. 3 divided by 3 is 1, so 5 divided by 3. When you type that in your calculator, you're going to get 1.6 repeating gallons. Okay, and I don't really like repeating decimals. Yeah, you could round it, but I just want to kind of keep it precise because it's my unit rate, you know. So I can also say instead of saying that, I can say this. Or that says or. 1 2/3 gallons per minute. Or I can also say 5/3 gallons per 1 minute. Okay? Because this is equal to this, which is equal to this, they're all equal to each other. So if you're like, what, 1 2/3, how is that equal to this? Well, 1, there's the whole number right there. 2 divided by 3 is going to give you that 0.6 repeating. There it is, okay? And the reason it's a 7 on your calculator there is because the calculator had to round it because it ran out of room, but it would literally be 0.666 repeating forever and ever and ever, okay? And then if you're curious about how I got the 5/3, I went 3 times 1, which is 3, plus 2 more is 5, and then keep that same denominator for that, okay? So those are all unit rates right there. Those are all equal to it. See how it's over 1? It's super weird to see like a mixed number over 1, you know, as a fraction. And then right here, an improper fraction over 1. It kind of looks weird, but it's not wrong. Table. Well, this is x, this is y. And remember, this is y divided by x. So I know that the y represents gallons. And then the x is representing minutes. And pick your values. I'm just going to go with my standard 1, 2, 3, 4, 5. And how long does it, and the reason I stopped at 5, in all honesty, is because, I mean, I could keep going, but I don't really want to, have giant numbers on here. And I do want to include these right here because I know that it's asking me questions. So I'm kind of trying to be smart with my space this time around. How long does it take to fill half the 5-gallon bucket? Well, think of this, half the 5-gallon bucket. What's half of 5 gallons? Half of 5 gallons is 2.5 gallons. Okay, so I got to figure out how long it's going to take to fill 2.5 gallons. So I'm going to keep everything as a fraction because I don't want to be typing in 1.66666 repeating for that unit rate. So that's how I'm going to write it. I'm going to write it as probably this. Okay, so it's 1 2/3 gallons per 1 minute. And I am concerned about filling it 2.5 gallons, how long that's going to take. All right, so this might be a little bit weird looking, but it's okay. What did I multiply 1 2/3 by to get 2.5? Well, you just gotta go 2.5 divided by 1 2/3, okay? 2 5/10 divided by 1 2/3. So 1 fraction bar, 2 fraction bar, 3 equals, 1 1/2. So I'm going to multiply this numerator by 1 1/2 to get this one, and I multiply this denominator by 1 1/2 to get this one. 1 times 1 1/2 is 1 1/2 minutes. That's how long it'll take, okay? And do I have 2 1/2 gallons? Oh, I don't. Let's go ahead, since I have room, you know I planned ahead. And that took how many minutes? 1 1/2. And then how many gallons are in the bucket after 2 minutes? Oh, I already have that. Oh, it's already there, so I can just look at that too. And I think I'm just going to do that because I don't really have room. Okay, the unit rate is 1 2/3 or 1 2/3 gallons per minute, or 5/3 gallons per minute, or 1.6 repeating per minute. I'm going to go ahead and I'm going to write this one right here. So times 5/3, that's 0, times 5/3, because 5/3 is the same as those other ones right there. It might look weird because you're like, I don't see 1 in the denominator. Well, it is right there, okay? Okay, so 1 times 5/3 is 5/3, or 1 2/3. 2 times 5/3 is 3 1/3, or 10/3, same thing. Okay, 3 times 5/3 is 5. 4 times 5/3 is 6 2/3. Or you can be like 18, 20/3, same thing. 5 times 5/3 is 8 1/3, okay? So we can answer this question right here. How many gallons are in the bucket after 2 minutes? 3 1/3 gallons. And I didn't just cheat. We just looked at it, and it was right there. So that's your evidence, okay? So the ordered pair that represents the unit rate is 1 5/3, or you could say 1 1 2/3, or you could say 1 1.6666 repeating, okay? All right, for the graph, here's x, here's y. X represents minutes. That says minutes, sorry. Y represents the gallons. Okay, in minutes, let's see here. That's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, for the gallons, I'm going to count by the unit rate. That right there is 0. This would be 1 2/3, or you could write 5/3. This would be 3 1/3. This would be 5. This would be 6 2/3. This would be 8 1/3. Wait, hold on, I can stop right there, can't I? Yeah, this is only a 5-gallon bucket, so I can just stop right there. We don't need that. Because you can't fill a 5-gallon bucket more than that, because it would just overflow. Cool, so I can stop. I didn't need any of this right there. Okay, because our maximum was 5 gallons. That's under 5 gallons, that's under 5 gallons, that's under 5 gallons, that's under 5 gallons. So we're good. That's the most it could be. Wow. Okay, so that makes this graph so much easier. So after 1 minute, they would fill it 1 2/3 gallons, or 5/3 of a gallon. After 2 minutes, they would go 3 1/3 gallons. After 3 minutes, they would fill the whole 5-gallon bucket, and that's it. And of course, we can have like 1 1/2. We can figure out how much it is for like 1 1/2 minutes. Remember, 1 1/2 minutes would be right here, and then the corresponding value for 1 1/2 minutes was 2 1/2. which would be about right there. 1.5 minutes, 2.5 gallons, so it's right there. And this makes sense to connect it because, like we just found, we can have, at the minutes, we can have fractional minutes. And I'm not going to put an arrow because it stops right there. It doesn't keep going because it's only a 5-gallon bucket, okay? But this is a proportional relationship because it's linear and passes through the origin. All right, so our equation, y equals unit rate. Gosh, you have your pick for unit rates right here because it's all interchangeable. 1 2/3 times x. You could also write y equals 5/3 times x, because it's 5/3 over 1, you know, technically. Y equals 1.6 repeated over, 1.6 times x. X in all of them represents the minutes. And y in all of them represents the gallons. Okay, and these are all the unit rates. I don't think I need to label them, do I? All right, explain why 1 2/3 is equivalent to 5/3. Okay, this last page, you're on your own, okay? Here's a situation. It costs $6 to play 2 games at a carnival. Find the unit rate. How many games are played if the cost was $81? How much would it cost to play 47 games? Here's your blank table. Here's your blank graph. Remember to label everything. Here's your blank equation slot. And I want to know, which is your favorite way to represent proportionality? Using a table, a graph, or an equation? And how come? Why was that your favorite? Okay, bye.